Hello. We are continuing examples that deal with properties of exponents in section 3.1. So let's have a couple more here to look at. So we notice on part F that everything is being raised to the third power. And so when I'm looking at this, I need to remember that that power of 3 has to be given to every single part inside. So if we separate these by multiplication dots here, you can see that there's 3 things at the top that we're going to be giving that 3 to, and then also 1 on the bottom. So let's start by this. Let's distribute that power of 3 to the 2. So we have 2 to the third power. And then we're going to do that same thing, but now let's give that power to our x term. So when we do that, we've got x squared all raised to the third power. Now we need to also give that power to the y. So I have y squared all raised to the third power. And then this is going to be all in the numerator, and then we've got the z squared that also needs a power of 3. So z squared raised to the third power. Okay, so now let's just take and let's simplify this more, right? We can see there's some simplification that needs to happen here. So let's go ahead and do that. So my 2 to the third power means 2 times 2 times 2, which is 8. Then x squared to the third power. So we've got a power raised to a power this time. So when we have this, that's when we multiply those exponents together. So 2 times 3 is 6. So we end up with x to the 6th power. Similarly here on y squared raised to the third power. 2 times 3 is 6, so we're going to have y to the 6th power. And then on the bottom, we'll have z also to the 6th power. Then you want to take a look at it and see if there's anything that you can reduce with the coefficients, and there's not. You want to make sure that all the x's are together, y's are together, and z's are together, and they are. And you also want to check and see if there's any negative exponents. And there's not, so we know that that is all the way simplified now. Okay, so now let's take a look at this last one, part G. We have something similar going on here, but notice this time that the power of 3 is just going to be given to the parts in the numerator, where in the denominator, it has a different power that it's being raised to. So everything inside the parentheses here is going to be raised to a -1 power. So let's go ahead and try this again. So 3 raised to the third power. And then we're going to have x raised to the third power. It's really like x to the first raised to the third power, so I'll write it like that. And then y to the fourth needs to be raised to the third power. Our z needs to be raised to a power. So this time we've got z to the -3 still raised to the third power. All right, so we gave everything in the numerator, that power of 3. Now let's go to the denominator and give everybody in here a power of -1. So I've got 4 raised to the -1 power. I have x to the 6th raised to the -1 power. And so, let's see, so x to the 6th raised to the -1. Now I'm going to have my y. So I've got y to the first raised to the -1 power. And then I've got z to the -4 raised to the -1 power. Okay, So let's go ahead and do the simplification that we can see that we need to do here. Now, so 3 to the third power is 27. 3 times 3 times 3. And then I'm going to go ahead and do the other part on the bottom that kind of corresponds with this, right? So 4 to the negative 1 power, remember when we have a negative power, it's not telling us to multiply the 4 by negative 1, it's telling us to flip that 4. So that 4 is unhappy downstairs. So we're going to flip him upstairs where he's going to be happy. So I'm going to just put 4, and now it's to the positive first power. I'll put that there. You don't need that there, but that might help you remember that we just flipped it up. Okay, then our x's. So remember, a power raised to a power is multiply. So I've got x to the third power. And then on the bottom, I have x to the negative 6th power. Let's look at our y's now. Now this is a power raised to a power, so again multiply. So 4 times 3 is 12, so y to the 12th power. And then on the bottom there, we've got y to the negative 1 power. All right, now let's look at our z's. All right, so here we've got negative 3 times 3. So here we've got z to the negative 9th power. All right, those properties of multiplication are still in play. So make sure you remember negative times a positive gives you a negative. So we need to write it that way. And then on this, we've got negative 4 times negative 1. So that's going to give us a positive 4 now. So z to the positive 4th power. All right. Okay, so now we need to see that we've got a lot of negative exponents here, and we need to move those negative exponents, right, to where they're going to be happy. So remember, if they're negative on the top, right, they're not happy there. We're going to flip them to the bottom, they'll be positive, they'll be happy, right? And same thing with the ones on the bottom are going to flip up to the top. But let's go ahead and multiply those coefficients out first. 27 times 4, 108. Now our x's, we've got an x to the third on the top, so it's happy there. We're going to keep it there. But this x to the negative 6 was not happy downstairs. It wants to flip upstairs, which will make it positive. Now let's do the same thing with our y's. Y to the 12th, it's already positive, so keep it where it's at. Y to the negative 1 in the denominator is going to flip upstairs. And now our z's, that z to the negative 9, right, does not want to be up there. It's going to flip downstairs, so we're going to have z to the positive 9, and then z to the 4th was happy where it was at, so we'll leave it there. All right, now we just need to combine the x's together, the y's together, and the z's together, and we're going to use that property of products here where we're going to be, since it's connected by multiplication, let's add those exponents together. All right, so let's see, what do we get when we do that? So let's leave that 108 where it is. Our x's, when we add 3 and 6 together, we get 9. With our y's, when we add 12 and 1 together, we get 13, so y to the 13th power. And then our z's are on the bottom. 9 plus 4 is 13, so z to the 13th power. All right, and now we know that's all the way simplified because we check for those 3 things that we talked about, right? Reducing any coefficients if we can, get the x's together, y's together, z's together, and then make sure we have no negative exponents. I hope that was helpful for you.